Now let us talk about recursion. This adjective recursive, it means defined in terms of itself. Recursion means calling itself. If you Google this recursion, you'll get the answer as did you mean recursion? Surely will give like this. And as computer scientists or computer related people, we frequently run into recursion in the form of recursive functions. Those who have learned C or C++ or any other language, they might be aware of this recursive or recursion, which is actually calling itself or themselves, maybe directly or indirectly through another function. But we are going to see some applications of this recursive definition through some examples. Here, if you want to compute factorial, let us start with this factorial. This is n exclamation mark. So how this in mathematics this factorial is computed? First of all, we multiply n by n minus 1, n minus 2 till 1. And this is the mathematical representation of the computation. And for this, what we are going to do, we are going to use this recursion. So factorial, and this is not by recursion, this is general method. Factorial, we have defined int p equal to 1. This is called the terminating condition, or say p equal to 1. And this will be regarded as terminating condition when you will deal with the recursion. This is a for loop from I equal to 1 to n, and this is p into is equal to I. So this is actually equal to p is equal to p into I, right? So every time what will happen, p is 1 because we have declared or initialized it as 1, so it will be 1 initially, then I will be 1. Okay, so p will contain 1. For the first iteration, p will contain 1. For the next iteration, now this p, again this will be computed. So p will have what? 1. And this has gone to be 2. And this will be given to p. So next iteration, p will contain 2. And again in the next iteration, this will be 2. This will be, because I will increase, so this will be 3. So 2 into 3. This is how up till 5. So actually we are getting 5 into 4 into 3 into 2 into 1. So exactly we are going to get the value if we are computing the factorial of 5. So this is perfectly valid. But what we are trying to learn, specifically with data structure in our mind, that we want to compute it through recursion. So as I suggested, that there has to be a condition where this loop or the factorial is going to stop. This is by 0 factorial, and you know that 0 factorial is 1, and n factorial is n into n minus 1 factorial. And this n minus 1 factorial, will be again n minus 1 into n minus 2 factorial, and this will grow, right? So what we are going to do is factorial into n. If n equal to 0, return 1. This is a terminating condition because we need to come out somewhere. Else return n into factorial n minus 1. We see that we are calling this factorial n, and then inside we are calling a factorial n minus 1. Once this will be called factorial n minus 1, this function will be revoked or invoked again, and here it will be n minus 1, and this will be n minus 2, till the time this factorial becomes 0, and we know that when n equal to 0, it will return 1. So if we start with 5, it will go to 4, 3, 2 and 1, and at 1 it will end. So the function factorials will call itself. So this is a recursive implementation. But this may be at the first instance seem somewhat complicated, but don't worry, we'll be seeing more example on this. So what is the plan? The plan is we multiply n by n minus 1 and then by n minus 2 and so on till 1. So this is a recursive solution, and we treat it as black box. This black box is actually the black box, means black box testing and black box thing. This is what when we mean when we say black box, because the parameter n-1 we are not aware, because n-1 is going to give rise to n-2, and till the time 1 will come. That is why we are just inserting 5, say n number, or we are taking it 5, and will come up to 1. So let us distribute this factorial 5 to various students. A student which is responsible for computing factorial 5, and the other one which is responsible for computing factorial 4. So 5, the person is dependent on factorial 5, and on the other hand factorial 4 is dependent on the person or a student who is computing factorial 3. So here the dependency is there, but the complete thing is black box, and the dependency is right from factorial 5, the student who is computing factorial 5, to the student who is computing factorial 1, right? And these intermediate results are very important. But let us see, because I just wanted to introduce that stack thing, but let us learn more aspects so that we can go to that memory thing. Now, one more thing is, as far as this recursive function is there are few things we need to remember. First is, you have to have a base case. Base case means it has to stop somewhere. It has to stop somewhere. If it is not going to stop, it will eventually run out of stack memory. So now, if you are doing recursion, you understood that without me saying, you understood that this recursion will keep the variables in stack, and you have to have a base condition. And the recursive calls must have smaller inputs. That means n should call n-1, n-1 call should n-2. So recursive call always have to have a value less than it, smaller than it. Okay. Before I go ahead, I need to emphasize, we need to see certain examples violating some certain condition, and we will know that okay, this is our problem, this is what we have not to do. Okay, this is a factorial. If n equal to 0, return 1, and return else return whatever will be the name. But we see that okay, at first glance everything is good, but if you see closely, n equal to 0, return 1, it is okay, but you are calling again n, here also n. No, this is not going to work, because as I suggested, this has to be lower than this value. So error will be input not getting smaller. Let us take one more example where the problem may arise. This is, you are passing n, return n into the factorial function name n-1. So again, at a first go, this function is okay, but this is not going to stop. Why this is not going to stop? Because you don't have any terminating condition. So this is not going to terminate at all, right? So these two things you have to keep in mind, that you have to have a calling value greater and called value smaller, and there has to be an end condition. Let us go to this binary search and try recursion on this. Binary search, let me introduce what is binary search. If there are some numbers from n to n, and if they are sorted, then what we do, we find out the midpoint. Searching is finding a value in certain numbers, in a group of numbers. So we go to the midpoint, and if we could not find the value, and this value is greater than the mid value which we are trying to find, we'll check this way, otherwise we'll check this way. So in this way we are reducing the complexity by half. But what about what is the role of recursion in here. Just take an example. This is a binary search. We have low as 0 and high as length. Length is n. This is the n. So we named it as length, and mid is the midpoint. So while low is less than or equal to high, this will only happen when there is no value, because you could not find the value. And the mid will be this high or plus low, that is 1 plus n by 2, or 0 plus length by 2, high plus low by 2. And once your value is found, we return the mid. If the value is exactly in between, it is being returned. Otherwise, what we do, we change. Means now this will be the first value, this will be the last value. If you are going this side, or if you are going this side, this will be the first value and this will be the last value. Again, we are going to find out the center point. So if this n is less than the value, then the high value, means the high value will be mid minus 1, this mid and minus 1. So 1 and a value which is just before this will be the value. So in this sequence, we are going to find out only this sequence. Otherwise, we'll take low to mid plus 1, means this was the mid, okay, this was the mid. We'll just take a value ahead of it, and this will be regarded as the low, and the higher one will remain there. So this will go on and will return minus 1. Why we are returning minus 1? Find the location of target element, or return minus 1 if it is not in the array. If the array is not containing that value, we will return minus 1. This is how in programming we use it. Now let us do it with recursion. In recursion also, we have done the same thing, because this is an array. In star b is array. In star b is an array. N is the length, means n are the number. Low is low, high is high. So if high is less than low, again the termination condition is this only. So if high is less than low, then we return 1 minus 1. Okay, this is a terminating condition, and we really require a terminating condition in your recursion. Else what we do the same thing. Mid is high plus low by 2, and this we return mid. We found it. Else what we do, if the value is, this is high and low, if this side we do this, if this side we do this, and we call this recursive search again by putting this value nb low mid minus 1, and we are again calling it, and this is the element, this is the element to the left of the midpoint, and this is the element to the right of the midpoint. So how this can be elegantly done, if this code snippet can show you. So whether you are using iterative or recursive solution, it totally depends on your taste, but we can really use recursion to our use. And one thing you will be wondering about, how many values are there? There are so many values, n, b, low, mid, minus 1, all these values are there. So how we are going to deal with this? The value means what is the value variables n, l, low, high, mid, n. All these values are there, but don't worry about that, because once it has been invoked, the others will not be touched, and your operating system will take care of this. This will be stored in stack and translated into memory locations by your compiler and OS. Right? So this is just an example to show that how we can get the binary search completed. So hope you got idea about recursion. We'll talk about this more. So till then, thank you.